TMI cortical bone grinder, all electric driven, designed for 1,000 micron sizes down to 125 micron size cortical bone. Side view of the grinder itself with the side panels off for maintenance purposes. Small compressor, that's a permanent piece. The compressor itself is used for nothing more than keeping pressure on a bone push cylinder to keep a constant feed into the cutting tools. 3 horsepower motor linked into a 50-to-1 gear reduction box. All the gearing that was in there was set up with special sized bearings, the brass parts. Wiring is all set up on a harness. The face of the bone grinder without the cutting head assembly. These are drive shafts, and also showing some sealed bearings to keep bone from migrating. Lower section of the cutting head assembly, which by the way is made up in 2 pieces, so that we have something small enough to fit into a autoclave. The secondary cutters are matched pieces and actually run within each other's grooves, and they rotate in the same direction. These are rakes that also comb bone out of the secondary cutting tools, and they're easily set in place there and will be tied down on the side with some thumb screws, and all matching precisely so that we don't have any broken teeth. This is the thumb screws here showing how they hold the brakes in place. There's also been a second mounting block that's on top of this, the one you are now looking at. This is the main shaft that'll hold the primary cutting tool, the one that actually is sized to cut bone at least 1,000 micron size. There's also a knife off to the upper left of the shaft and near the key that helps cut bone precisely. 2 short bearings that go on the secondary shafts. One has already been installed. You can see where the upper block is already in place here. Face itself taps on easily. Bone collection box. Mounting holes are slotted on that so that it's easy to mount and remove the collection box. Thumb screws that hold the front plate in place, and all they need to be is hand tight, no over torquing. The bone push cylinder, which is pneumatically driven with a compressor, it's in the belly of the grinder. Detent pins that hold the cylinder in place. They also make contact with proximity switches, so if these pins are not in, the machine cannot run. If one or more are taken out, the machine again will not run. Larger thumb screws there so that we can have sufficient torque on the top and bottom. Nylon 11 tubing, which by the way is autoclavable, fits into swivel fittings. This shows the rectangular push pad on the rod end. When it's open, it will not operate. When you put the pin in, it will operate. Your controls there to extend or retract, and also emergency stop. It's also the same button that starts the unit. Motor switch there, forward and reverse, and it's also a neutral on it. If any bone ever gets stuck, you can back it up and kick it loose. Cortical bone shafts from a femur now being inserted into the loading chamber. A whole donor may be ground before anything's ever removed. Pins in place, motor on, and she should start grinding. The cortical bone being ground right now. Primary shaft breaking it down to 1,000 micron size. One 1,000 micron size bone falling into the secondary cutters, which will break it down to as low as 125 micron size. In this same area, we can also remove the secondary cutters and just with the primary cutter cut cancellous bone. Unit being taken apart so that all parts may be placed into an autoclave. The bone itself shown in its powder form. It's estimated that a total donor can be ground within 20 minutes time. Jack screws to help break the plate loose so that all these sections again may be placed into an autoclave. The upper and lower blocks of this cutter head assembly are made out of hard anodized aluminum, so they're not overly heavy and ease for an operator to put them into a pan for autoclave. At the end of a grind, all bone can be dumped back into a collection pan and sieved out. whatever bone is too large that lays on top of the secondary cutters may be put back into the grinder. A total grind with the TMI grinder should give you at least a 96, 97, in some cases a 98% yield of good bone. It's designed not to waste bone. This is some of the residual bone there that can be put back into the grinder at the end of a full donor grind. This is the finished product.
Okay.
And this is residuals that was left over. So we'll just take this and dump it back in for a second grind.